Let's solve this problem. If you'd like, you can click the pause button and try to solve this problem yourself before you watch the video. We have two circles intersecting each other at points A and B. CE is equal to 5, CF is equal to 2. Let's connect point F to points A and B. FA and FB are congruent and equal to R as radii of the smaller circle. Let's connect point E to points A and B. EA and EB are congruent and equal to 2R as radii of the larger circle. Triangles FAE and FBE are congruent by 3 sides. FA and FB are congruent, EA equals to EB, and FE is shared by both triangles. Therefore, angles AEF and FEB are congruent. Triangle AEB is an isosceles triangle. EA is equal to EB. And since EC is the bisector of angle AEB, EC is also a median and an altitude, because in an isosceles triangle, the bisector of angle formed between two equal sides is also an altitude and a median. AC is equal to BC and AB is perpendicular to FE. Triangle FAC is a right triangle. By the Pythagorean theorem, AC squared is equal to AF squared minus CF squared. Let's sub in the values. AC squared is equal to R squared minus 4. Triangle EAC is also a right triangle. By the Pythagorean theorem, AC squared is equal to AE squared minus CE squared. Let's sub in the values. AC squared is equal to 4R squared minus 25. Let's equate these two expressions, and after simplifying the equation, we are left with R is equal to square root of 7. Using this formula, we can find AC, which is equal to square root of 3. And since AC is equal to BC, AB is equal to 2 square roots of 3. Thank you for watching. If you found this video helpful, please like and subscribe to the channel. Thank you.